Let me stop playing here. Hello, viewers. Morning. Another beautiful day. Hope your five senses work. Hope the strength is good. Or excellent. What? What's this? What, Tuesday? Wednesday morning? Alright, I got something for y'all. What's up, gamers? Alright, what I got for you? Let's see, what's this here? What's up, Tom's Hardware? Hardware, that is. What do we got here? Oh, listen to this. This for you Nvidia fans. Says here, Nvidia Neural Rendering Deep Dive. Full detail on Dlss 4, Reflex 2, Mega Geometry, and more. Says here, AI technologies will play a big role in the upcoming RTX 50 series. All right, Tom's Hardware. Let's see what you're talking about here. Let's do this. Says here, during CES 2025, Nvidia held an Editors Day where it provided technical briefing on a host of technologies related to its upcoming RTX 50 series GPU. It was an all-day event kicked off with neural rendering session that covered topics including Dlss 4, multi-frame generation, neural material, mega geometry, and more. AI and related technologies will be front and center on the RTX series, though some of the big upgrades will also work on existing RTX GPU. Going all the way back to the original 20 series Turing architecture, we also have separate articles on the Blackwell architecture, RTX 50 series Founder Edition cards, RTX AI, and generative AI for games, Blackwell for professional and creators, and how to benchmark Blackwell and MFG. There's a tons of information to cover, and we have the full slide deck for each session. It says, due to time constraint, Intel Arc B570 launched tomorrow, and there's still all the testing to get done for the RTX 5090 and 5080 launches. Later this month, we won't be able to cover every aspect of each discussion, but let us know in the comments and questions you might have. We'll do our best to respond and update these articles with additional insight in the coming days. Then it says, neural rendering session was full of interesting information and demos, most of which should be made publicly available. We'll add links to those if and when they go live. At high levels, many of the enhancements stems from the upgrade tensor cores in the Blackwell architecture. The biggest change is native support for the FP4, and then it says in parentheses, 4-bit floating point, close parentheses, data types with thorough output that's twice as high as the prior generation FP8 compute. Nvidia has been training and updating its AI models to leverage to enhance the cores, and it lumps these all under the Blackwell neural shader header. Then it shows a picture here. Need to bring it up. Anyway, says here, Nvidia lists 5 new features: neural textures, neural materials, neural volumes, neural radiance fields, and neural radiance cache. Read through the list fast, and you might start to feel a bit neurotic. Says here, we already discussed some of the implications of the neural materials during Jensen's CES keynote, where featured games could potentially reduce memory use for texture and materials by around 1/3. That will require game developers to implement the feature. However, it won't magically make any 8 gigs GPU include the RTX 5070 laptop GPU, and most likely unannounced RTX 5060 desktop GPU work better. But for games that's leverage the feature, they could look better while avoiding memory limitations. Says here, Nvidia is working with Microsoft on a new shader model called cooperative vectors that will allow the intermingling of tensors and shader cores, aka neural shaders. While this should be an open standard, it is not clear if there will be any support for other GPUs in the near terms, as this very much sounds like an RTX 50 series specific enhancements. It's possible to use these new features on other RTX GPU as well, though our understanding is that the resulting code will be slower as the older architecture don't natively support certain hardware feature. And then it shows a picture of the original and then the RTX skin. Says here, Nvidia also showed off some update of Half-Life 2 RTX Remix sequence with one enhancement called RTX Skin. With existing rendering techniques, most polygons end up opaqueous. RTX Skins use all training to help simulate how light might illuminate certain translucent object, like the above crab. There was a real-time demo shown which looked more impressive than the skill image, but we don't have a public link to that yet. And then it says another new hardware feature for the RTX 50 series is called linear swept spheres. While the name is a bit of a mouthful, its purpose is to better enable the rendering of ray trace hair. Modeling hair with polygons can be extremely demanding. Each segment of a hair would require 6 triangles, for example, and with potential thousands of strands, each having multiple segments, it becomes unwieldy. Nearly swept spheres can trim that 2 spheres per segment requires 1/3 as much as data storage. Then it shows a picture here again of the 30 year of increased geometry. That is shows from the 1900, 2000, 2010, 2020, next generation. Alright, says here the number of polygons in games has increased substantially over the past 30 years. High-end games in the 90s might have used 1,000 polygons to 10,000 polygons. Virtual Fighter 3. Anyway, says here per scene, recent games like Cyberpunk 2077 can have up to 50 million polygons in a scene. With Blackwell and Mega Geometry, Nvidia sees that increasing another order of magnitude. It says, interestingly, Nvidia mentioned Unreal Engine 5 nanite technology that does cluster-based geometry as a specific use for case Mega Geometry. It also specified call out BVH, bonding volume hierarchy, and then it says though the may be specifically for ray trace use case. Says Nvidia shows a live tech demo called Zora both during the keynote and during this session. It was visually impressive, making use of the many of these new neural rendering techniques. However, it's also a tech demo rather than an upcoming game. We suspect future games that want to utilize these features may need to incorporate them from an early stage, so it could be a while before games ship with most of this tech. Then has the video here, so I will leave the link. It says here the second half of the neural rendering session was more imminent, with VP of Applied Deep Learning Research Brian Cantizaro leading the discussion succinctly. It was all oriented around DLSS 4 and related technologies. More than anything else, DLSS 4, like the RTX 40 series, DLSS 3, will be the key to unlocking higher level of performance. And we must put that in quote because despite the marketing type, AI generated frames aren't going to be entirely the same as normally rendered frames. It's frame smoothing times 2. Says here, Nvidia notes that over 80% of gamers within RTX graphics cards are using DLSS and is now supported in over 540 games and application. As an AI technology, continuing training helps to improve both quality and performance over time. The earlier DLSS version used a convolutional neural network for their models, but now Nvidia is bringing a transformer-based model to DLSS. Transformers have been at the heart of many of the AI advancement of the past 2 years, allowing for far more detailed use case like AI image generation, text generation, etc. Says here, with the DLSS transformer model, Nvidia has twice the number of parameters and it uses 4 times the compute, resulting in greatly improved image quality. Moreover, gamers will be able to use the Nvidia app to override the DLSS mode on at least 75 games with the RTX 50 series launch, allowing the use of the latest models. Then it says above are 2 comparison shots for Alan Wake 2 and Horizon Forbidden West, showcasing DLSS transformer upgrade. Alan Wake 2 used for full ray tracing with ray construction, which apparently runs faster in addition to looking better than the previous CNN model. Forbidden West was used to show off the improved upscaling quality with greatly increased level of fine details. We haven't had a chance to really dig into DLSS transformers yet, but because on the early videos and screenshots, after years of hype about DLSS delivering better than native, it says the quality, it could finally end up being true. Results will likely vary by game, but this is one of the standout upgrades, and it will be available to all RTX GPU owners. And see here, it says here the DLSS transformer models do require more computing, and so many run slower, particularly on older RTX GPU, but it's possible we could see DLSS performance mode upscale 4x with the new models that looks better and perform better than the old DLSS CNN quality mode times 2 upscaling. And it says here, I'm almost done here. It says here, we're less enthusiastic about the multi-frame generation MFG, if only because of the amount of marketing hype behind it, with the new hardware flipping metering to help smooth out things, coupled with faster frame generation algorithm. On one hand, MFG makes sense. Instead of interpolating one frame, you generate three. Poof, 3 times the performance uplift. But on the other hand, that means 1/4 the sampling rate. So if you're running a game with MFG and getting 240 FPS, that really rendering at 60 FPS and quadrupling that with the MFG, and that specific example would probably look and run great. What will be more problematic is games and hardware that can't get 240 FPS. For example, an RTX 5070 might only run at 120 FPS. What could that feel like? Question mark. And it says, based on what we have experienced with DLSS 3 frame generation, there's a minimum performance level that you need to hit for things to feel okay, with a higher threshold required for games to really feel smooth. With single frames generation, we generally felt like we need to hit 80 frames or more. So a base frame rate of 40 with MFG, if that same pattern holds, we'll need to see 160 FPS or more to get the same 40 FPS user sampling rate. Says here, more critically, frame gen running at 50 FPS, for example, tends to feel sluggish because users input only happens at 25 FPS. With MFG, the same experience will now happen if you fall below 100 FPS. Says here, of course, you won't see perfect scaling with our frame gen and MFG. Regular DLSS 3 frame gen would typically give you about 50% increase in FPS, but Nvidia often obfuscate this by comparing DLSS plus frame gen with pure native rendering. If you're running at 40 FPS native, you did often end up with 60 FPS after frame gen and a reduced input rate of 30 FPS. What sort of boost will we see when going from a single frame to 4x MFG? That might give us closer to direct doubling, which could be good, but we'll have to wait and see how it plays and feel in practice. Then it says, Nvidia own example in the above slide suggests the performance improvement could range from as little as 33% Alan Wake 2 to as much as 144% Hogwarts Legacy. But that using an RTX 5090, again, we'll need to wait and see how this work and feel on lesser 50 series GPU. And then it says, wrapping things up, the other big news item will be Reflex 2. It will eventually be available for all RTX GPU, but it will first be available with the RTX 50 series. Where Reflex delay input sampling until later in the rendering pipeline, Reflex 2 makes some interesting changes. First, our understanding is that based on past and current input, it will project where the cameras will be before rendering. So if, as an example, your view has shifted up to 2 degrees over the past 2 input sample based on timing, it could predict the camera will actually end up being shifted up to 3 degrees. Now here's where things get wild. And it says here, after all the rendering has finished, Reflex 2 will then sample users' input once more to get the latest data, and then it will wrap the frame to be even more accurate. It's a bit like a synchronous space wrap used with VR headset, but the wrapping here could cause this disclusion, so that weren't visible are now visible. Reflex 2 addressed this with a fast AI in-painting algorithm. And it says here, the above gallery shows a sample of white pixel that are missing. At the Editor's Day presentation, we were shown a live demo where the in-painting could be toggled on and off in real time, while the end result will depend on the actual frame rate you're seeing in a game. Reflex and Reflex 2 are at their best with higher FPS. We suspect the wrapping and in-painting might be more prone to artifacts if you're only running at 30 FPS as an example, while it will be less of a problem in game running at 200 FPS. Not surprisingly, Reflex 2 will be coming first to fast-paced competitive shooters like the Finals and Valorant. 800 FPS. Anyway, says here, and that's it for a neural rendering session. The full slide deck is available above, and we gloss over some aspect. A lot is going on with AI. Needless to say, we're particularly curious to see what happens with things like neural textures. Could we see that applied to a wider set of games? We asked Nvidia about that, and it sounds like some game studios might be able to opt in to have their assets recompressed at runtime, but it will be on a game-by-game basis. Frankly, even if there's a slight loss in overall fidelity, if it could take the video RAM requirement of some games from 12 to 16 gigs and reduce that to 4 to 6 gigs, that could grant a new lease on life to 8 gigabytes GPU. But let's not count those chicken until they actually hatched. Yep, and that's the end of the article. So yeah, yeah, Nvidia, man. It's a nice little article, man. So I had to read it for you guys. You know, some of you guys don't like to read your articles, you know, so I had to do that for you. But anyway, you know, Tom's Hardware just gave us an overview of what Nvidia got plans as far as upscaling and technology goes, from the 50 series to ray trace to path trace, everything included. So yeah, I don't see no comments on this article, so I guess people haven't read it yet, but I read it for them, so I give them about they should thank me for it. But anyway, I'm joking though. But anyway, yeah, there's a video here. Let me see what this. How long is this video?
Okay, what do I owe you?
Let's see. How long is this video here? You know, they got to go through these short commercials. Let's see. What are we talking here? It's about 1 minute and about 36. 1 minute and 36 seconds. And they got 714 comments. So yeah, Nvidia, man. Yeah, they're on the move, man, with their AI. You know, they jumped on that AI train and they skyrocketed. You know, and then AMD had to follow suit. Like, you know what? We'll jump on that train too. You know, so Intel doing the same too. So yeah, AI it is, man. So 50 series. Yeah, you know, I did a video a couple days ago, or a day or two ago, about Valorant running at 800 FPS, man. I wish Tom Hardware had a video to show me that, man, but they didn't. But I guess this one, since it's 1 minute and 36 seconds, it will make up for the make up for this. But yeah, video games, man. 800 frames per second. So yeah, Nvidia, they're making moves, man, and it's gonna be interesting to see how they how all this tech that they have, you know, helps out with the Switch too. It's gonna be interesting to see how that works. But anyway, yeah, 700 comments, 714 comments. So by the time I put this video link in this article, in the description box, you might be joining that 714 comments. But yeah, Nvidia, man, they're doing things. They got some slides here. What they got? They show ray construction with CNN model, ray construction, transformative model. They got a slide here. So how many slides is this? 2 slides. They got super resolution, CNN current, and then super resolution transformer. What else they got here? They got RTX neural rendering, and then they show the 3 pillars of real-time graphics. The 3 pillars of real-time graphics again. And they got some slides here. They got AI provide 10x leap in graphics. Nvidia Dlss. And then Dlss 6 years of continuous learning. Then yeah. What is a cat doing here? They got oh, this Nvidia showing a cat. Let's say curious cat. What's this? What's this? Imaging encounter. Anyway, because the arrows in the way, they got transformer core. Transformers comes to DLSS, and yeah, Nvidia, man. What else they got here? See if they got any. Actually, how many slides they got? Yeah, a couple of slides here. They got the video, and then they have they got the Blackwell brings AI to shaders, and then they have the what's this one? Yeah, Nvidia, man. So they got some things going on here. So I will leave the link of this video. Link the video in the article in the description box. But yeah, Nvidia is making moves, man, and it shows their what's this? It shows the. See if I can pick this up a little bit. Oops. Oh, here we go. Come on now. Okay, it shows the. What's this? The programming shaders. It shows from 2001, 2003, DX9, DX10, DX11, DX12. DX9 is 2003, DX10 is 2006, DirectX 11, 2009, DirectX 12, 2015, and DirectXR. That's when Nvidia and Microsoft did that little partnership. Yeah, so Microsoft will be involved in this, and that's where the new Xbox console comes into play. So yeah, Xbox gamers are gonna be loving this. Yeah, man. They're making moves, man. Making moves, man. Nvidia is at it. So yeah. Anyway, I'm gonna leave this video for y'all to enjoy, you viewers. Thanks for watching. Hope you enjoyed my reading. Nice talking to you people again. Chris, still Star Wars search. Thank Pork Dark Side. Go on. Peace.